Hello, and welcome to this introduction to construction estimating. Presented by Tech Training, LLC. Estimating is the art of trying to determine the probable costs of any given construction project. To be a successful estimator, an individual must consider all the costs that could influence a project. Every item and service must be analyzed, quantified, and priced. The construction documents are studied intently by the estimator because one of the most difficult parts of preparing the estimate is the fact that it must be done before any construction actually begins. An estimator becomes the most important person in any construction company when they can visualize every detail of the project and accurately determine its costs. For projects using the design, bid, build delivery method, contractors are required to submit a competitive cost estimate. The competition in the construction industry is intense, and many firms are competing for a single project. To stay in business, a contractor must be the lowest qualified bidder on as many projects as they can reasonably handle, all the while getting a reasonable profit margin for their work. The return a contractor earns must be acceptable to the amount of work they have completed and the amount of risk associated with the project. The most important trait of an estimator is the ability to visualize all the different phases of the construction project. This is especially difficult because the estimate is prepared from working drawings and the project manual. The working drawings usually contain information relative to the design, location, dimensions, and construction of the project, while the project manual is a written supplement to the drawings and includes information pertaining to materials and workmanship, as well as information about the bidding process. The project manual is often mistakenly referred to as the specifications because it contains the technical specifications, but it contains much more. In fact, the working drawings and the project manual constitute the majority of the contract documents. They also define the scope of work and must be reviewed together when preparing an estimate. The drawings and project manual complement each other and often overlap in information. The bid submitted must be based on the scope of work provided by the owner or the owner's representative. It is the estimator's responsibility to ensure that everything contained in the drawings and the project manual are included in the submitted bid. The estimator reads these documents thoroughly and in great detail. These documents have a high degree of complexity, and a single error could be extremely costly. One of the first things an estimator will do is review the plans and project manual to ensure that they are complete. Next, the estimator will begin the process of quantifying all of the materials in the project. Every item listed in the estimate must contain as much information as possible. The quantities determined by the estimator will be used for ordering and purchasing needed materials in the field. Furthermore, these quantities and their projected costs become the basis for project controls in the field. However, the estimated cost of the project includes more than just materials. As an example, there are direct costs and indirect costs. Indirect costs are also referred to as general conditions or project overhead. The direct field costs are the material, labor, equipment, or subcontracted items or items that are permanent and physically part of the project. For example, the labor and materials for the foundation of the building would be a direct cost. The indirect field costs are the costs for the items that are required to support the field construction efforts. This might include such items as the field office, vehicles, worker benefits, and we can't forget insurance, bonds, communication systems, and traffic control. Now, the project site office might be an indirect field cost, but other factors must also be included in the indirect costs. What about weather, transportation, soil conditions, labor strikes, material availability, subcontractor availability? All of this information must be gathered, considered, and quantified by the estimator. Regardless of the weather, labor strikes, or availability, the estimator must prepare as accurate an estimate as possible. Since subcontractors and specialty contractors perform much of the work in the field, an estimator must be able to calculate the scope of work in order to get accurate quotes from the subcontracting firms. Solid estimates require organization and estimator's judgment, subcontractor quotes, accurate quantity takeoffs, and accurate data of completed projects, also known as historical data. This historical data will be used in a conceptual estimate. A conceptual estimate is based on a project's concept. At this point in the project cycle, all that may be available is a vague verbal or written description of the project scope. Typically, drawings are not available or are limited to a few sketches. When this type of estimate is required, it is known as a conceptual estimate, and it requires the estimator to make assumptions regarding almost every aspect of the project. In conceptual estimates, historical data becomes priceless. The conceptual estimate is used early in the design process to check to see if the owner's wants are in line with their budget and is often used as a starting point to begin contract negotiations. During the design process, the contractor prepares and maintains a cost estimate based on the current but incomplete design. This is often referred to as a preliminary estimate. In addition, the contractor may prepare estimates that are used to select between materials or to determine whether the cost to upgrade the materials is justified. What all these estimates have in common is that the design is incomplete. Once the design is complete, the contractor can prepare a detailed estimate for the project. And a quick side note, there are exceptions to this rule, especially when using delivery methods such as design-build, where the design is being completed as construction proceeds. Now let's talk about specific estimating methods. As we just mentioned, a detailed estimate is not completed until the design is complete. The reason for this is that a detailed estimate costs a great deal of money and can take a great deal of time to complete. The required level of accuracy, combined with the amount of information available, will dictate the type of estimate that can be prepared. Each estimating method requires different amounts of time to complete, and thus produce different levels of accuracy. The relationship between time to complete the estimate and the accuracy of the estimate is shown here. The different estimating methods clearly show a different level of accuracy. But once again, other factors play a role. The amount of information available at the time of the estimate, or the size of the project. As an example, the project comparison method suggests a very quick estimate, but not particularly accurate. Let's assume this would be a bathroom renovation. An experienced contractor would walk into a bathroom, take a quick look around, and say $15,000. Here the 2 represents 2 minutes. But if the same contractor was given information from the homeowner, such as specific tiles, plumbing fixtures, lighting, etc., and requested a detailed estimate, the contractor may take 12 hours and produce an estimate which is almost 100% accurate. So now, let's review these various estimating methods. A detailed estimate includes quantities, costs, materials, and everything that is required to complete the project. Also included would be labor, equipment, insurance, bonds, overhead, and of course, an estimate of the profit. Again, detailed estimates can only be completed with a complete set of contract documents. Every item of the project will be broken down into individual parts and estimated. Each portion of the work that will be performed by a contractor will be given distinct labor requirements that must be estimated. Any item that will be installed by subcontractors must also be defined and priced. Caution is required when dealing with subcontractors and/or specialty contractors. When it comes to the contractual agreement, it must be understood whether there will be material supplied or material supplied and installed. Furthermore, support items must be defined in the contract, items such as cranes, scaffolding, and other major pieces of equipment. It is the contractor's responsibility to ensure the scope of work is divided between themselves and the subcontractors, so that there is no overlaps in the individual scope of work, but at the same time everything is included in somebody's scope of work. To simplify the definition of a detailed estimate, the detailed estimate is detailed. It includes the quantity of materials, cost of materials, required labor, cost of labor, equipment required, cost of equipment, overhead of each item, profit desired, etc. The complexity of the project, the amount of time invested into a detailed estimate, are big considerations when making the decision to move forward with the project. Next are assembly estimates. In an assembly estimate, rather than bidding each individual component of the project, the estimator will put components into groups known as assemblies. The components of an assembly may be limited to a single trade or may be installed by many different trades. For example, an interior door assembly might include the door, frame, hinges, trim, doorknob, shims, and nails, and the quantity of each part necessary to complete the work. When creating an assembly estimate, it would be listed simply as an interior door, instead of each individual part needed. Another example would be a light switch which consists of many different parts. However, in the assembly estimate, it would be simply listed as a light switch. An example of a more complex assembly would be a metal, stud, gypsum board partition wall, which would include bottom tracks, metal studs, top tracks, drywall, screws, tape, joint compound, insulation, primer, paint, and other miscellaneous items needed to construct the wall. This assembly would be installed by multiple trades, but listed as a metal stud partition wall. Many high-end estimating computer programs allow the user to prepare detailed estimates by taking off assemblies. For the switch assembly, the estimator would take off the number of switch assemblies needed for the project, and the software would add one single gang box, one single pole, one cover plate, 2 wire nuts, and 20 feet of NMB 12-gauge wire to the detailed estimate for each switch assembly. This simplifies the estimating process and increases the productivity of the estimator. Assembly estimating is also useful for conceptual and preliminary estimates. By using broad assemblies, an estimate can be prepared quickly for an entire building. For example, an estimate for a warehouse could be prepared using assemblies for the footings, foundation, floor slab, granular base, exterior walls, personnel doors, etc. This type of estimate can be prepared in hours instead of spending days preparing a detailed estimate. The trade-off is that this type of estimate has many broad assumptions and is less accurate than the detailed estimate. This type of assembly estimate is good for preparing estimates with limited drawings, which reduces the ability to compare design approaches. This type of estimate is also used as a check on detailed estimates. If the assembly pricing in this type of estimate is coming from a previously completed project, it is assumed that this project is identical to the completed project. This assumption is clearly not valid in the construction of certain types of buildings. Weather conditions, building materials, and systems as well as design and construction team members change from project to project, all adding to the uniqueness of each estimate. Skill and judgment must be used while preparing this type of an estimate to ensure that proper adjustments are made by taking into account the varying conditions of each project. Companies and organizations will publish annual guides such as square foot costs that contain pricing for specific assemblies. And speaking of square foot estimates, let's now move on to square foot estimating. Square foot estimates are prepared by multiplying the square footage of a proposed building by the cost per square foot of a previously completed building, or using some other form of historical cost data. This value is then adjusted to compensate for differences in the building's height, length, perimeter, and other building factors. In some cases, a unit other than square footage is used as a means to measure the size of a building. As an example, the size of a parking garage may be measured by the number of parking spots in that garage. The information required to produce a square foot estimate is much less than is needed to prepare a detailed estimate. In fact, a preliminary set of design drawings may have all the dimensions necessary to prepare a square foot estimate. Square foot estimates are quick, and in many cases used to check if a project is within budget. Like assembly estimates, broad assumptions are made. Care must be taken while preparing a square foot estimate. Most notably, the previous data or historical data used to determine the cost per square foot must resemble, as much as possible, the proposed project. Companies publish annual guides that contain a range of unit costs for a wide variety of building types. These guides include a number of adjustments that must be made to compensate for various building components, including location, size, quality, etc. There is also what is known as parametric estimates. Parametric estimates use equations that express statistical relationships between building parameters and the cost of the building. The building parameters used in the equation may include the gross square footage, number of floors, length of perimeter, the percentage of the building that will be common space, and so forth. For an equation to be usable, the parameters used in the equation must be parameters that can be determined early in the design process. Otherwise, the equation becomes useless. Parametric estimates, though similar to square foot estimates, are more complex. Parametric estimates use log functions, ratios of parameters, multiplication of parameters, and in some cases even more complicated equations. Parametric estimating is useful for preparing conceptual estimates based on assumptions of key building parameters or estimates based upon early designs. But again, like square foot estimates, like assembly estimates, parametric estimates use broad assumptions. Therefore, care must be taken to ensure that the proposed project is as similar as possible to the project from which the data has been derived. Next up is model estimating. Model estimating uses computer-generated models to prepare the estimate based on a number of equations answered by the estimator. Model estimating is similar to assembly estimating, but it requires less input from the estimator. For example, an estimate may be prepared for a warehouse by answering the following questions. What is the length of the building? How many bays are along the length of the building? What is the depth from the grade to the top of the footing? What is the floor thickness? Do you want wire mesh in the slab? Again, depending upon the details, the questions can go on and on. Now, based on the answers to these questions, the model prepares a preliminary estimate for the project. Logic is built into the model such that the model selects the necessary components for the estimate based upon the answers to these questions. As an example, the signs of the spot footings in the center of the building, supporting the roof, are selected based on the area of the roof that the footings support, which is equal to the width of the bay multiplied by the length of the bay. The length and the width of these bays are calculated from the first 4 questions previously shown. This type of model can make many assumptions, such as assuming that the exterior wall will be constructed of concrete masonry units. The model ignores site and excavation costs, which needs to be added to the estimate from the model to get a complete picture of the proposed costs. A big advantage to estimating models is the fact that they can be complex, preparing a detailed estimate for the entire project, or simple, preparing a preliminary estimate for only part of the project. And once again, it cannot be overemphasized that historical data used for modeling estimates must be as similar as possible to the proposed project. Another type of estimate is the project comparison estimate. These estimates are prepared by comparing the cost of a proposed project to a similar completed project. When preparing a project comparison estimate, the estimator starts with the cost of a comparable completed project and then makes the adjustments for the differences between the 2 projects. For example, an estimate for an apartment building may be prepared from an apartment building that was constructed in a nearby city with the same plans. In this example, the prices of the completed project are available, but need to be adjusted for inflation, changes in availability of labor and materials, as well as any code changes that may have taken place or are unique to the current location. Because of differences in site conditions, the site should be estimated separately when using the project comparison method. Now, let's talk about areas when estimating can bring in additional opportunities. There are many areas where knowledge of estimating is necessary. This also lets those interested in estimating identify potential career opportunities. A general knowledge of estimating is required by anyone involved or associated with the industry of construction. From the junior estimator, who may only be involved with specific material quantities and pricing, to office personnel who may be asked to order materials for a project. Estimating knowledge is needed to do the best job possible at the most competitive cost. Others involved in the estimating process include project designers, drafters, engineers, contractors, subcontractors, material suppliers, and material representatives. As an example, architectural offices need estimates throughout their design processes. Preliminary estimates, cost evaluation during drawings, and final estimates are all prepared during the design process. For projects built using the design, build, or construction management delivery systems, the preliminary estimate is often used during negotiations with the general contractor. Once the general contractor is hired, the general contractor's estimator will prepare the remaining estimates. In large offices, the estimating may be done by an estimator hired primarily to do all the required estimating. In many offices, the estimating may be done by the chief drafter, head or lead architect, or perhaps someone else in the office who has developed the required estimating skills. There are also estimating services or consultants who perform estimates on a for-fee basis. In an engineering office, there may be civil engineers, structural engineers, mechanical engineers, electrical engineers, and geotechnical engineers. All of these disciplines have design phases, which require preliminary estimates and final estimates. These estimates are prepared throughout the design phase, similar to an architectural firm. When it comes to a design bid-build project, the general contractor makes detailed estimates that are used to determine what the company will charge to do the required work. On projects built using the design build or construction manager delivery systems, the contractor's scope of work involves providing assistance to the owners, beginning with the planning stage and continuing through the actual construction of the project. Under these delivery systems, the estimators will also provide preliminary estimates and then update them periodically until the final price is set. Subcontractors can be individuals or companies who are masters of their trade. They handle such work as excavation, concrete, masonry, interior finishes, exterior finishes, roofing, flooring, and so on. These specialists do hire estimators and may even use estimating firms, but many of these subcontractors are so specialized they do their own estimating. Another opportunity for estimators is government agencies. When a government agency is involved in any phase of construction, personnel with experience in construction and estimating are needed. Included are local, state or federal agencies, including those involved in highways, roads, sewage treatment, schools, courthouses, etc. Employees may be involved in preparing or assisting to prepare preliminary and final estimates. Finally, there are also freelance estimators who will do material takeoffs on a portion of a project or the entire project for whoever may wish to hire them. These estimators may work for owners, architects, engineers, contractors, subcontractors, material suppliers, or manufacturers. In some areas, the estimator will do a material takeoff of a project being competitively bid, and then sell the quantity list to one or more contractors who intend to submit a bid on the project. Now that we have covered the various types of estimates and talked about various estimating opportunities, let's go through some basic estimating examples. What we are going to do here are conceptual estimates. Then we will review some estimates for specific applications and efficiencies. In order to get an accurate estimate, we've already determined that an estimator's skill, judgment, and methodology is critical. But also required is a well-defined scope of work, appropriate preparation time, and reliable cost information. Even in a conceptual estimate, there are certain items that must be considered. Consideration examples include the project size, the project quality, the project location, construction start date, construction finish date, and of course, the market conditions. The cost established from this type of estimate is normally used in the initial project planning stage. The number which is derived is normally accurate within plus or minus 20%. The price is derived from historical data, and in many cases is based on the cost per bed, cost per room, or some other variation depending upon the project. To perform this type of estimate, indexes are required. A historical index, or HCI, is a reference point to costs in the past. A current cost index, for CCI, is a reference to present costs. As an example, you are asked for a rough number for a school in Chicago, Illinois. You completed just such a school in San Francisco in 2011. The cost of the building in 2011 in San Francisco was $15.5 million. So here, we are trying to solve for the cost of the Chicago school today. We know the San Francisco cost was $15.5 million. We can also get a historical cost index of San Francisco in 2011 from various sources. RS means, ENR, just to name a few. We can further get a current cost index for the Chicago market from these sources. Let's take a look. We have a historical cost index of 354 for San Francisco in 2011, and a current cost index of 680 for Chicago in 2020. As mentioned earlier, the values of the corresponding indices can be found in many sources available online. And for now, this is all we need to come up with a quick price. To estimate the Chicago price, we have the San Francisco cost of $15.5 million. We also have the San Francisco Historical Cost Index of 354, and we have the current cost index of Chicago of 680. Therefore, we simply want to solve for the Chicago school cost, and we do this through cross-multiplication. We take the $15.5 million multiplied by 680 and divide this value by 354. That gives us a result of $29,774,011.29, and we'll round it up to $30 million. Now, since we know this is a conceptual estimate, the owner, in this case the City of Chicago, would have to add another 20% to this estimate and ask themselves if $36 million is within their budget for the new school. Now, let's go ahead and try a conceptual square foot estimate. These types of estimates are based upon historical square foot costs of similar buildings. An estimate of this type would be done when only approximate size and minimal project information is known. These estimates are considered to be accurate within plus or minus 15%. We have been asked to provide a square foot conceptual estimate for EDU books for a 15,000 square foot library they're considering building in Texas. The only information we have received is EDU Books does not want the price to be based on average quality. Let's start by looking at quality and how price quality is determined. Here we see square foot costs for libraries. Costs such as these are also available for hotels, motels, nursing homes, etc. But for now, let's stick to our library. These costs are also based on average size, in this case 14,000 square feet. We can see at the top unit costs, and we see three separate categories: 1/4, median, and 3/4. These categories are adjusting the cost for quality. The median cost represents the cost at which 50% of the library projects used in this analysis were more expensive, and 50% were less expensive. The 3/4 value suggests a higher quality project where only 25% of comparable projects were more expensive, and the 1/4 suggests a lower quality where only 25% of the projects are less expensive. Upon review of historical data, one of the first pieces of information we discover is a 17,000 square foot library. Again, in 2016, costs $720 per square foot on a national average. The reason the larger library has a lower square foot cost is the system works into the calculation and efficiency adjustment. In other words, as the construction crew works on a larger facility, they become more efficient as time goes on. Of course, the increase in efficiency is only realized to a certain point. Some other information we find through our historical data research is New York built a 13,000 square foot medium quality library in 2016. Furthermore, the city cost indices for New York 2016 is 97, while Texas was 65. Lastly, there has been a 3% per year inflation rate since 2016. Let's take a moment and tabulate the information that we have. New York built a 13,000 square foot median quality library in 2016. The city index for New York in 2016 was 97, while in Texas it was 65. We also have an annual inflation rate of 3%. Lastly, again for 2016, a median quality 14,000 square foot library costs $750 per square foot, and a 17,000 square foot median quality library costs $720 per square foot. Keep in mind, these square foot costs are based upon national averages. Now, EDU Books is still waiting for an answer. So let's break this down into 3 steps. First, we will adjust for size. We'll do this by getting a price for a 15,000 square foot library in New York in 2016. Next, we will adjust for location of the new library in Texas, but we are still in 2016. And finally, we will adjust for the inflation rate, which is also making our adjustment for time. So first, let's get our square foot price. We can do this through interpolation. Don't worry, this is not going to be on any quizzes. It is for informational purposes only. The 17,000 represents the larger library, and the 15,000 represents the size of the library we want to build in Texas. The $750 is the cost per square foot for the median 14,000 square foot library, and the $720 represents the cost per square foot of the 17,000 square foot library. And if we do out the math, we should get plus 20, which we are going to add to our $720 per square foot price. That gives us a price of $740 per square foot for our 15,000 square foot library. Now, some people do this calculation differently. Many people create an equation which states X is the unit price we are trying to determine. The ratio determined by having 17,000 minus 14,000 over 720 minus 750 is equal to the ratio obtained by having 17,000 minus 15,000 over 720 minus X. And again, if we do out the math, X equals $740 per square foot. So now that we've determined the unit price of $740 per square foot, we simply multiply by the size of the library EDU Books wants to build. $740 multiplied by 15,000 square feet equals $11,100,000. But this cost is still on a national level. We still have more information, so let's now move on to Step 2. In Step 2, we will adjust for the size because the New York City median quality library had an area of 13,000 square feet in 2016. But any area above the 13,000 square foot value would have a less expensive square foot cost, again due to the efficiency of the construction crew, which is developed over time. To get the cost adjustment for the size, we first calculate the size factor. We obtain the size factor by dividing the new area, 15,000 square feet by the median quality area, 13,000 square feet, again in New York. This gives us a size factor of 1.15. Now, to modify our cost, we will use the cost modifier chart. This is the cost modifier chart. We enter with the size factor 1.15, which is on the x-axis. Follow the red arrow going vertically up. After we hit the cost modifier curve, we project that value on the y-axis to obtain a cost modifier that is approximately 0.98. Now, to get our new price, we simply multiply our $11,100,000 by the cost modifier of 0.98. This gives us a cost of $10,878,000. This is the cost of a 15,000 square foot median quality library in 2016. We now have to adjust for location and time. So now we can adjust for location by using the same formula as in our previous example. Here, the New York cost over the New York index will be equal to the Texas library cost over the Texas index. The New York cost is $10,878,000. The New York index is 97. The Texas index is 65. And we are solving for the cost of the Texas library. And the cost is $7,289,381.44. But we are going to round up to $7,300,000. This is our cost for EDU-Books Library in Texas, 2016. We now have to adjust for time. So our final step is to adjust for inflation, or increased cost over time. You may recall in our previous example, we used historical cost and current cost indices. In this example, inflation is making the time adjustment. So, in 2017, the price of the building would be $7,300,000 plus 3%, or $7,519,000. And the cost in 2018 would be $7,519,000 plus 3%, as the inflation is cumulative. But an easier equation is $7,300,000 multiplied by 1 plus 3 over 100 to the power of 5, 5 representing the number of years. And if we do the equation, our total cost for EDU-Books Library in Texas 2021 should be $8,462,700.74. But again, we will round up to $8.5 million. And figuring in the accuracy factor of plus or minus 15%, we would inform EDU-Books the cost may be as high as $9,775,000. So we've taken a median quality 13,000 square foot library in New York, built in 2016, and given our client a price on a 15,000 square foot library in Texas in the year 2021. Literally in a matter of minutes. This is the importance of historical data. Now, a good estimator would, even in a conceptual estimate, make adjustments for labor, materials, equipment, inflation escalations, market conditions, and other criteria. But again, this is not a detailed estimate. It is a rough number, which is usually produced in less than an hour, and therefore its accuracy is always questionable. But let's review a few of these items, and let's start with materials. Material costs are usually the most straightforward. This is because, in most cases, the source for the price is the supplier. But the estimator must still be sure the prices quoted are covering all of the specifications. Some items the estimator should review are: does the price include delivery? Though this may seem obvious for some materials, in many cases delivery is not included. How long is the price valid? Almost all quotes have a good until date. If the material will not be used until the future date, the price may be significantly different by the purchase date. Warranties always have to be considered. What are the payment terms? Are there discounts for quality paying early? Are escalations built into the price? And, most importantly, are the correct materials being quoted? This may seem simple, but consider concrete. 6,000 psi concrete is far more expensive than 3,000 psi concrete. Large pieces of equipment such as dozers, cranes, lift trucks, and alike are used on a project-to-project basis. The equipment is usually needed throughout the project, and therefore all costs must be considered. To simplify these costs, equipment is usually put into separate categories, the equipment itself at the cost of operations. Labor can be a difficult item to price because wage rates and crew productivity must be considered. We will discuss this in a moment. However, some of the items that must be considered by the estimator include amount of overtime anticipated. Will this be a working day job, or will work be performed on nights and weekends? Is skilled labor available in the area? If there is a lot of work going on in the area, skilled labor may be at a shortage. Are there hazardous conditions on the job? More hazards mean more regulations, and this means more cost. Is this a union project? If so, the estimator must familiarize themselves with union rules and regulations. And what is the expected efficiency rate? This information will greatly assist in setting the schedule. And time is money. So let's finish this presentation by taking a look at crew efficiency and how to tie that estimate to a construction schedule. In many cases, estimating is tied to a schedule through a crew's efficiency. This is done by assigning the durations for the activities. Durations are the estimated time that it's going to take to complete a particular task. But, depending upon the schedule, we have to use specific units of time. In most cases, it's going to be days. When these days are put into the schedule, it is assumed that the tasks are done on a continuous basis, meaning standard working days within the work week. Many times, an estimator will tie the estimated cost to the estimated time to complete a task through calculations. As an example, the quantity of work times the efficiency rate, established through historical data, will equal the crew hours. Then we can use the crew hours and divide by the hours in a day to give us how many days a particular task is going to take. To emphasize this technique, let's do a couple of examples. Scaffolding is to be constructed on all faces of a 6-story building. 4 major masonry work to take place. The surface area of the building has been established as 432,000 square feet. Historical records from the company show for this type of structure, the production rate for erecting scaffolding is 0.002 hours per square foot of building surface area. 10 workers working 8-hour days are assigned to do the entire scaffolding erection. If each worker is earning $40 per hour, what is the cost of scaffolding and the duration in working days that should be used for this activity? So, here is our quantity of work. It's 432,000 square feet. Our efficiency rate is 0.002 hours per square foot. Therefore, the entire task is going to take 864 hours at $40 per hour. Our estimated cost is $34,560. As for the duration, we need 864 hours with 10 workers, or 86.4 hours per worker. Since each worker is putting in 8 hours per day, it will take for 11 days to complete this task. We can now apply 11 days to this task schedule, along with the cost of $34,560. Let's take a look at another one. 6-inch by 6-inch tiles can be installed at a rate of 50 per worker hour. The floor of a large lobby area, 80 feet by 40 feet, is to be covered with these tiles. If 3 workers are assigned to this task, each earning $65 per hour, what is the cost and duration that should be assigned to the activity? In order to cover 1 square foot of the lobby, we need 4 tiles. Therefore, the amount of tiles can be calculated as 80 feet times 40 feet times 4, or 12,800 tiles to cover the entire lobby. So, our quantity of work is 12,800 tiles. Our efficiency rate is 50 tiles per hour, per worker. This means we need a total of 256 hours for 1 worker, or 85.33 hours for 3 workers. This gives us a total estimated cost of $16,640 for the entire project. Finally, if each worker needs to put in 85.33 hours, and they are working 8 hours per day, the entire project should take 10.67 days or 11 days. Once again, we now have an estimated cost for the task and a duration to put in our schedule. Of course, the best way to determine duration is through historical data. Many successful GCs employ the same people over and over again because they have historical information which indicates that a particular subcontractor gets a particular task completed within a given period of time, which the GC can feel confident in. And if you know with good accuracy that someone is going to accomplish a particular task within that given time, it helps the GC as the GC becomes more profitable because their estimates of time and money are more accurate. So in this presentation, we've covered types of estimates, estimating opportunities, conceptual estimates, estimating considerations, and estimating efficiencies. And this concludes the Introduction to Estimating, presented by Tech Training, LLC.